Good morning. I'm Ryan Mitchell. I am the guy behind The Tiny Life, and we basically talk about tiny houses, minimalism, and homesteading. So I want to talk about today electrical for your tiny house, because I know a lot of people have questions about that, especially if you want to go off grid, which I am. So we're going to walk out here to where it all starts. That's with the solar panels. I have a 4,000 watt solar array, and that's suited me pretty well. It's a pretty large system, frankly. Most of it's just designed to actually handle my air conditioning and heating. I do that all based off electric. So here's 3 sets of 3, and then I got 2 more sets of 3 here. They're all wired up in series parallel. I have a post on Tiny House Solar. You should check that out if you're interested in that. So all that kind of comes together and runs down a wire to what I call like my utility closet. And this is actually a separate little enclosure that captures all of my power and stores it. So I'll give you guys a little view here. So that's like all the things that make it work. And there's all the batteries, okay? Kind of show you guys. So, let's just get out there, we go. So let's talk about the parts of this real quick. Even though this isn't a solar kind of video, I know people have a lot of questions. This is the inverter, okay? This is a little control panel, the main breaker. Right here is the charge controller. I actually have 2 of them. You can see right there, right there. And then there's breakers basically between everything. You'll find if you do solar, you have a lot of breakers or fuses to make sure that each component's isolated if something goes wrong. The batteries down here there are, let's see, 12 of them, yeah. And that's, they're each 6 volt wired in series, so that gives me 24 volts. And then they're like 360 amp hours each. So, and we have 3 of them. So 3 times 360 is my amp hours. And if you want to know kilowatts, because I know a lot of people ask that, you take the volts, which in this case is 24, and you times it by the amps of these batteries, which the amp hours here are 360 per string. So you can do the math there. Because amps times volts equals watts. We talked about that in the post here down below where this video is posted. If you're on YouTube or something like that, click in the description. There'll be a link directly to the post. So this is where kind of all the power gets made and converted and stored. And then from there, you can see this really big wire that comes out of all this from the inverter, and then it comes into my tiny house right here. So this is a 50 amp plug. It's basically meant for RVs, and I have it as a plug because then it's technically a temporary connection, which is great because I can just roll up into a like RV park or campground and just hook up with their existing connections. And then also with building codes, the distinction between a temporary power connection and a permanent hardwired connection is a really big one. So sometimes that's a sticking point for building inspectors. So that's why I chose the plug here. This actually just like pulls out like a giant plug. Because it's technically a temporary connection. So yeah, it just hasn't been unplugged in 7 years. So that's where all the power goes in. On the back side right here is your standard breaker box. It's just on the inside here. It's a little bit hard to get to, but you know, I'm not gonna show you that. You guys know what breaker box is, but it's basically set up like a sub panel. And that's where all the power comes in, and it's distributed throughout the whole house. And for me, I broke mine up into a lot of different circuits. Like I had a couple circuits in the kitchen, one for the loft, one for each side of the house and things like that. And then one to each of my major appliances, which in this case are actually right here. This is a on-demand hot water heater. It uses propane, but I have it on a separate circuit. It doesn't use much power. It's really just for the igniter and the heating coil if it gets too cold. And then here is my mini split, and this is the big energy suck. This thing was the most efficient one on the market when I bought it. It still is, outperforms most of what's sold out there, but it takes about 60 to 80% of the power that I generate when I do need to heat or cool. And that is a 240 connection, which just kind of a side note, your inverter here, if you're going off grid, make sure that it can do 120 and 240, because that's a lot of them like try to save money and get in at a lower price, which seems like a good deal until you try to run things like your air conditioner. That could be a real challenge. In the actual house is, here we go this way here, nothing special. It's really just all LED lights. I use a lot of puck lights and a fan as kind of like my main light here. And after that, there's nothing really special about it. It's just standard electrical stuff. So you can kind of follow the same convention that you would with any home, and how you wire it, the actual connections, which wire you use, the outlet, all those kinds of things, which I get into in the post here. So if you'd like to know more, definitely check the link in the description, or if you're already on the post, just scroll down. Again, my name is Ryan Mitchell, and I appreciate you guys checking out this video about tiny house electrical. Thanks.